Hello everyone, I'm Sandhya Christie, Assistant Professor ECE HiSet, and today's topic is flip-flops. Flip-flop is a circuit that maintains a state until directed by the input to change the state. A basic flip-flop can be constructed using 4 NAND gates or 4 NOR gates. For sequential switching networks, the output depends on both present input and the past sequence of inputs. Since we depend on both present input and the past sequence of input, we need to remember the history. The next one is flip-flop is a memory that has a pair of complementary outputs. Types of flip-flops. There are basically 4 types of flip-flops in digital electronics. The first one is SR flip-flop, the second one is JK flip-flop, the third one is D flip-flop, and the fourth one is T flip-flop. Now let's see about D flip-flop. D flip-flop is an electronic device that is known as delay flip-flop or D flip-flop, which is used to store single bit of data. Using two gated D latches, the output changes occurs at the rising edge. Clock is high, then the output follows the input, and the clock is low, the output remains the same. When it comes to working of D flip-flop, the D flip-flop consists of a single input D and the two outputs. The basic working of D flip-flop is as follows. When the clock signal is low, the flip-flop holds its current state and ignores the D input. When the clock signal is high, the flip-flop samples and stores the D input. The value that was previously fed into the D input is reflected at the flip-flop's Q output. For example, if D is equal to 0, then Q will also be 0. If D is equal to 1, then Q will also be 1. For the second output, that is the Q bar or Q2, the flip-flop is complemented by the Q output. If Q is equal to 0, then the Q bar will be 1, and if Q is equal to 1, then the Q bar will be 0. In D flip-flops, the output can be changed at the clock edge, and if the input changes in other terms, the output will be affected. The change of state of output is dependent on the rising edge of the clock, and the output Q is the same as the input and can only change at the rising edge of the clock. The next one is T flip-flop, that is the toggle flip-flop. T flip-flop, or to be precise, is known as toggle flip-flop because it can be able to toggle its output depending upon the input. T here stands for toggle. Toggle basically indicates that the bit will be flipped, that is either from 1 to 0 or from 0 to 1. Here a clock pulse is supplied to operate the flop, hence it is called as clocked flip-flop. In T flip-flop, it has only single input. When T is equal to 1 at clock edge, the toggle flip-flop changes its states, and if T is equal to 0, there will be no changes in the state. Next, the truth table is T is 0, Q is 0, T is 0, Q is 1, and T is 1, Q is 0, and T is 1, Q is 0. The output will be remain the same. 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, and 1, 1 is 0. Q bar, that is the output, is equal to T bar Q plus T Q bar, that is equal to T XOR Q. The next one is SR flip-flop. This is the most common flip-flop among all. In this flip-flop, with the help of preset and clear, when the power is switched on, the states of the circuit keeps on changing, that it is uncertain. It may come to set Q is equal to 1 or reset Q bar is equal to state Q bar is equal to 0 in many state. In many applications, it is desired to initially set or reset the flip-flop, that is the initial state of the flip-flop that needs to be assigned. This simple flip-flop circuit has a set input S and a reset input R. In this system, when you set S as active, and output Q would be high and Q would be low. Once the outputs are established, the wiring of the circuit is maintained until S or R go high or power is turned off. For the truth table, if S is equal to 0 and R is equal to 0, the output Q will be 0 and Q bar will be the complement of Q1. For 0 and 1, the output will be 0 and Q bar will be the complement of 0, that is 1. And for S are 1 and 0, the output will be 1 and Q bar will be the complement of 1, that is 0. Here in 1-1 condition, the output is remain undefined. The next one is JK flip-flop. It is one kind of sequential logic circuit which stores binary information in bitwise manner. It consists of 2 inputs and 2 outputs. Inputs are set J and reset K, and their corresponding outputs are Q and Q bar. JK flip-flop has two modes of operation, which are synchronous mode and asynchronous mode. Due to undefined state in the SR flip-flops, another flip-flop is required in electronics. The JK flip-flop is an improvement on the SR flip-flop, where S is equal to R is equal to 1 is not a problem, whereas S is equal to R is equal to 1 is a problem in SR flip-flop. The input condition of J is equal to K is equal to 1 gives an output inverting the output state. However, the outputs are the same when one tests the circuit practically. If J and K data input are different, that is high and low, then the output Q takes the value of J at the next clock edge. If J and K both low, then no change occurs. If J and K both are high at the clock edge, then the output will toggle from one state to other. JK flip-flops can function as set or reset flip-flops. JK flip-flop is equal to SR flip-flop plus toggle flip-flop, allows J is equal to K is equal to 1. This case works like a toggle flip-flop. Split T to J flip-flop. JK Q and Q bar is equal to JQ bar plus K bar Q. In this table, 0, 0 and 1, 0 condition represents the Q and hold state. 0, 0 and 1, 0 condition represents the reset state. 0, 1 and 1, 1 represents the set state, and 0, 1, 1, 0 represents the toggle state. The toggle state is if the output is 0, Q is 0, then the Q bar will be 1, and if Q is equal to 1, the Q bar will be 0. Thank you, students.